I mean, I don't know about the expert part. But yeah, that Paul wrote that.
He'll be presenting applying user-centered design techniques for augmenting human perception in cyber warfare. So please welcome Frank Kelly.
Thank you. Thank you. So before we get started, I hate to hear myself talk, so please, rather than wait for a Q&A at the end, at any point, if you have something that you're curious about, just throw a tomato or ask me a question, it's fine. So this is applying user-centered design techniques for augmenting human performance in cyber warfare. The gestation, the kind of conception for this type of concept was a result of the DARPA Plan X contract. There was a cyber warfare contract that was released earlier, and they had a task area 5 associated with intuitive interfaces. I was the lead tech writer for the winning proposal for that effort to kind of construct what the future in terms of the interface to the soldier, how to perceive that data is going to be conducted. So to get right into it, cybersecurity has an interesting problem that I don't think that we're quite aware of yet, and that's that we have the requirement to deal with a set of data that is far faster, far larger, and far more complex than the human mind can possibly conceive. It's just bigger. So it requires us to have a new approach to the way that we do product development, to the way that we approach how to solve those problems, the way that we interact with that data. Not just the visualization, but also how that data is chunked and abstracted, filtered, and presented to the user in terms of the information architecture. Right away, you're probably thinking, okay, this is a GUI guy. He's going to talk to me about GUIs. That's true. I am going to talk to you about GUIs. But mostly, human-centered design is about using user research with product intent to develop a customer solution that gives better meaning in terms of associating how do I use the data and then how do I have actionable intelligence out of that data. It's about generally the workflow that we get from all the products that you see is collect the data, format the data, present the data. That's what we get. That's the way that our tools work. We have sensors out on the network. They collect the data. It formats it in a way that might be useful, might not be, and then it presents it to me. So one of the things that we did as part of this user research is we embedded ourselves in the cybersecurity operations centers for a military agency that I will not name so that they don't come after me, and my previous company. And we studied the user, how they act, how they interact with the data, how they interact with each other, what things do they need, what things do they see on screen, what do they have on screen that they're not using, and we develop user artifacts that allow us to construct designs that maximize the customer solution, that maximize the meaning behind the data. That's essentially what we're doing. One of the interesting things we found in this military agency that will go unnamed is that they have a lot of data that they present to one another, but they don't use very much of it. In fact, in any specific workflow, for 89% of the time during a 12-hour shift, they would use about 12% of the data that was available to them. And I remember I walked in, people pointed this out before. I asked you, okay, what's this interesting graph that you have here in your operations center? And, oh, that's the server temperature. I mean, okay, who cares about that? No one. So what this... Yes. So yeah, so each user had a 12-screen setup. Well, 89% of the different workflows they have, for instance, I've received a request for an injection. I need to do some type of activity. They would use 12% of the data that was on these 12 screens. There were occasions that they hit the peripheries of that data, but it does show that they're receiving a lot of data that they don't need. So normally you'd be like, well, that's fine, they don't need that data. Well, every time we have the interactions with that, it creates additional cognitive load on the human mind. There's just limits that we have there. But to get right into it, what user-centered design is anyone familiar with user-centered design or user experience? Okay. Commercially, it's a proven type of concept. Apple, the guys, Johnny Ivey at MIT Media Labs, and some of those guys have been very, very successful about applying commercial applications of user-centered design. How do I use my phone? How do I make it very intuitive? How do I have a high level of user delight? We don't care about things like user delight as much. And if you try to tell a general, hey, your soldiers need user delight, then they're going to throw something at you. I've had that happen. That's why I'm really good at dodging things now. What we care about is addressing that original problem. That I have lots of data, it's fast, it's complex. How do I approach it? How can I make the design enable me to have better understanding? This is critically what user-centered design is. It's about defining, through user research, the user needs and the product objectives. From that, developing functional requirements and customer specifications. Not, hey, I've got a great technical tool, this is going to be awesome, let's have the user try this and it not work. It's about understanding what does the user need, not necessarily what they want, that's another story there, and building requirements off of that need. Continually iterating and creating the information architecture, how that data is presented, what data, when, and where, and then creating the interface design, how we interact with it, how we navigate it, how we want it to be perceived. When we're finally done and we've moved from that abstract level of the user needs to the concrete actual prototype that they'll be interacting with, we've already achieved a high level of user buy-in and a high level of interaction capability, because it's derived from what the user needs. By the way, if I'm going too fast or something like that, sorry. This is the user-centered design process. If you think that it looks like Agile, you're right, it does look like Agile. It's kind of based on the same type of cyclical, iterative type of principles where you innovate based on a research and an understanding of the users, how they think, how they function, what are they like. If you think that this sounds a little bit squishy, it is quite squishy. We do develop personas of these users. What is this user like? So for instance, with the DARPA Plan X contract, the requirement was for these Title 10, Title 50 soldiers in Virginia and Annapolis to be able to engage targets from from source to destination with a variety of these tools. And they were giving him phenomenal detail about the way that the tools interacted and how they worked. The problem was, this is a 2-year-old kid right out of school, right out of training. He doesn't have an understanding of how that tool works, and you know what? He doesn't need to. He just needs to know how to make it work. The challenge is not, well, the problem is the user. The solution is the user. We build around who has the responsibility of doing that task. So you see, we conduct the research, run through iterative use cases, and then continually prototype, develop very low fidelity prototypes, evaluate the success with the user until we get closer and closer to a product that we can validate. Any questions so far? I won't go a lot into this, but it involves a lot of different elements in this user-centered design process. Everybody is involved, whether that in product strategy folks at the back end, what are the problems with the understanding the context, to the users, the heuristics of the existing tools. You know, we incorporate any number of different ideas, including ideas solved in other places. I was talking before we got in here that there's a lot of overlap where we can pull in the way that other problems have been solved to create these better solutions for users until we get to from kind of a planning state to a delivery state. So, who is the user? Not this guy or those guys, especially the guy with the toothbrush in his mouth. Also, I am not the user. And in a lot of cases, you guys are not the users. The user is whoever is going to be using the product we developed, the final authority. That's a detachment, especially for those of us that are involved in producing something for a customer, that I'm not that person, that we have to have a certain level of detachment from our own desires, because we bring in those own ideas of what the user should be doing, what the user should like. If we ever say that the user should, then we're not being effective in bringing the meaning to the user. So there are 5 different pieces I want to quickly run through about bringing meaning to the user. There are 5 different elements that are important: perception, visualization, the right time, right data, right form, context, and actionable value. And this is what we mean by that. And this is where the industry starts to fall apart and why we need user-centered design. This is an example, and these are, please understand, I worked very hard to get some real-world examples up on the screen. There are a lot of companies in town that produce products. I did not want to, call their baby ugly, but the babies are all ugly. Not my kids. My kids are cute. So here's a good example of this is what we see when we see cutting-edge cyber visualization, especially for network topology. It looks just like this. The problem is that data clustering in this way means that I can't see what's going on. The problem here is there's no indicator of the actionable intelligence out of here. In another example, tree maps. These are a big favorite for some research groups up north. They want to have everything associated here, and this is fantastic. There's actually a ton of data here and a lot of meaning. The problem is the human mind wasn't built to conceive this. You think about a heads-up display in a plane. Everything is exactly where I need it. You've got the, I don't know how to fly plane. I guess they have a speedometer. They've got all the little dials and stuff that you need right there, right where they should be to give me the vital information that I need to fly a plane. But if I want to fly two planes at the same time, it becomes a little bit harder because I have a very tactical view about what's going on with that plane. Well, what if I have a challenge, for instance, where the government wants a single drone operator to fly 1,000 planes at the same time? Do I still give them a heads-up display? Probably not. We have to have a better understanding because the focus of the user is shifted. We have to change the way that we give them the data. It's all still correct, but because the user has changed, our approach needs to change. One of the things that we have a challenge with is the consequences with the visualization that we see. Essentially, every cyber battle map that I've ever seen out there superimposed our cyber network topology over top of a physical network topology. I was telling somebody before I started it here is that I was speaking at a panel and this Air Force general said, you know what I need? I need from you guys is to give me a map where I can see where my cyber missiles, where my cyber mortars, and where my cyber bullets. How many bullets have I got, and how do I fire those cyber bullets, and what's the range? There's no such thing, and it's not his fault. The problem is they're adapting kinetic warfare methodology to this cyber battle space because when I see that that's where the good guys are and that's where the bad guys are, I assume that that's what the network is actually like. I assume those properties, that there are things like range or distance or things like that matter. They don't. When we have visualizations that introduce those concepts that I recognize inappropriately, it starts to cause problems. The right time. Here's an example of the right data at the wrong time. Same type of situation that we've talked about before where this data is all correct. This is Ether 8, by the way. But I can't do anything with it. Some of the data is correct, but I'm getting too much of the data. I need the correct data when I need it. Here's an example of wrong data, right time. I have an alert. It's the right time for me to receive some information, but bad error code file vmemc line 715. Actually, I do know what that is. When we give a user information like this that's not associated, doesn't have the right kind of connection for the cognitive process, I've caused what we call a high level of usability friction for the user. The right data, the right form. This is an example of you guys may have seen this before, of a denial of service attack on a university. There's actually a lot of excellent things that we can see about this, but without the right form, without the context, there's nothing that I can do with this. I can see that I'm obviously getting some things I can interpret about the flow of the data here, and that they're obviously targeting a single node here, but without any other type of information, this visualization is essentially worthless. This one I love. And somebody will get throw something at me for this one. This is Wireshark, obviously. And it's a tool that I use. And we can think, yeah, I know how to use that tool. That's not a hard tool to use. Well, for someone that's coming into the industry new, or from somebody who's trying to digest, think about the number of elements that we have there. It's very difficult to correspond the data elements here with anything else that's going on the screen. One of the things we notice in the cybersecurity operations centers is this disjunction of workflow where I'll use a single tool here, and then I have to stop and I break, and I have to bring in another tool here, and I have to bring in another tool here, because none of the tools talk to each other. They don't have any context with one another. So a human is essentially having to store complex resolutions about data and pass those on to other workflows. And I'll give you an example of one of those workflows in just a little bit. And lastly, actionable value. This is from a pretty cool demo of a denial of service attack underway. This is actually a really good approach because I can see exactly where everything is going, but I can't do anything with it. It looks really pretty, but it doesn't give me the next step. And that's the critical element for this visualization problem that we have, is that we have, like I said, collect the data, format the data, present the data. But if I don't give the user an intuitive way of, now what? Then I'm basically stopping the process. I'm short-circuiting what's going on. So, why does cybersecurity need user-centered design? I thought this one was pretty interesting. And that's me, actually, by the way, on the right. I had more hair then. The problem is we have a high level of complexity. I talked about this before, is that the industry that is out there that is doing this type of design thinking is approaching low data problems, low complexity problems. And let me give you an example of that. Cyber users are what we would call extreme users. They have data requirements that are more massive, faster, more dynamic, more complex than anything else that's out there. It's very difficult to design for these folks. In fact, I think the cybersecurity, this is my opinion, I think the community has stumbled into this. And the way that we address this problem is going to have an impact on a massive number of other technologies. We've approached this same type of thing, and the people that are interested are not just the cyber warfare professionals that are figuring out, how do I understand these massive networks? How do I understand how I'm under attack? How do I figure out what to do next? It's biomedical research, genomic research. We've stumbled onto a problem because we've essentially created an animal infinitely bigger than ourselves. And it's going to be interesting to see how the community approaches that. This is to give you an example of a comparison. So most of the design thinking that occurs out there has to deal with small data interfaces. And this is, when I talk about the small data, there's an example between what we call the intrinsic cognitive load and the germane cognitive load. The intrinsic cognitive load is how hard is a problem to solve just based on the problem itself. 2 + 2 = 4 has a finite amount of intrinsic cognitive load. Now, the tool that I use to solve that can either add to that problem or make it worse, or add to the problem or make it easier. So if I'm adding complex numbers, obviously I've increased the intrinsic cognitive load of that problem. If I add all kinds of other little cool digits in there, and I start multiplying, subtracting. Now, if I have a calculator, the system is solving those problems. If I can type it in very easily, I've got the germane cognitive load is very low. So, for example, email, iTunes, these are low intrinsic cognitive load problems. How do I play this latest album that I've got? How do I send an email? Those are easy problems. And so they require just solutions that have just low germane cognitive load. Hard problems, logistics, packet analysis, those are things that are much more difficult to conceive. So when we're building these interfaces, there's a theoretical limit to that usability. I can design until I'm blue in the face, but if I just make things more Apple iTunes-like or Android OS-like, it's not necessarily going to make things easier. We're trying to get to a point where we have a neutral level of germane cognitive load, where the system itself doesn't make it any harder. I'm not solving the problem. I'm figuring out how to use the system that solves the problem. By the way, also, everything about printers ever is terribly designed. Also BlackBerry. So here is the solution that we have, and the solution that the cyber industry is going to have to create in order to solve these problems. So if we scale it up with these are the hard problems, the things that we're facing, the cyber warfare, where are things at, the dynamic nature of cyber warfare, these are extreme problems, unfathomable intrinsic cognitive load. And what I mean by that is the human mind is not able to conceive even slightly the magnitude of these problems. When we first approached DARPA, they said, here's what I want. I want to be able to see everything that's on the web, everything, simultaneously. I said, okay. That's 83 billion or so assets. If I do 1 pixel per, we'll just make a screen the size of the Superdome. And he said, that's not my problem. So it was a big problem. Those are the types of things that we're having to face. They remapped the internet every 3 days. It took them 3 days to remap it up at DARPA, and then they would go from there with their cyber targets. And everything shifted and everything changed. It was a massive intrinsic cognitive problem. The problem is that no matter how well I designed Wireshark, I am not going to be able to see the packets transitioning across 83 billion assets. I just won't. So what the government is big on, some enterprises in the industry are big on, and what I think the cybersecurity community needs to be big on is this concept of system-supported decision-making. Also, it'll be referred to as something called decision advantage. And that's where the system and the human attempt to achieve human-computer symbiosis, not by jacking ourselves in the back of the head in the Matrix, but by deciding what are the things that the human does well, what are the things that the system does well, and then designing around the bottleneck. It's us. Deciding what do we need to do in order to solve those problems. And that's where the user-centered design will come into play. These are the cognitive barriers associated with how we start to introduce these massive, extreme problems. The number of steps, if I have to click through 6 different things to get what I want. And critically, at the end of each thing, it's all about what I want. Regardless of what that user need is, that's the intent of the user. How do I send that email? There's a reason why send is big right there. A great example of the sticky nature and how user-centered design is manipulated and manipulates the user in commercial industry is, if you'll ever notice, the user research from Amazon stated that people only care about 3 things. I said 3, and I did 2. 3 things, that's all that they care about. They care about the picture, they care about the price, and they care about the reviews. So when you go onto Amazon, the first thing that people want to see is they want to see the picture. Big sales if you have a picture, low sales if you don't. They want to see the price, it's all right there. But if you want to see the reviews, you got to scroll down to the bottom. Past all here are the other things that you might want to buy. Oh, here's some other people that like this. That's how the what I want is manipulated to allow you to get what they want. So, but as we, from that example, as we go through each one of these and we think about the product strategy, the end is the critical element is what does the user want? What does the user need there? And each one of these things adds in a different level of cognitive load. And every time we do this, we make that original intrinsic cognitive load problem harder. So these are examples of it done right. There is a reason that I use some gaming examples, because the game industry has figured out how to do it right. Everyone is, everyone, there's a lot of talk about, hey, we need to adopt gamification. It's going to be great. And we're going to do all these things. We're going to gamify all of our stuff, and we're going to have all these benefits. And what that ends up being is that I sign my time card every day, and achievement unlocked, you signed your time card. That's not gamification. The strength of gamification is the way that we've structured the interface to abstract out things that are complex or boring. I promise, and Tim can vouch for me on this one, weeding my garden is not fun. Farmville is fun. So, Yeah, it's terrible. The gamification abstracts those elements that are difficult. It enables humans to make the strategic decisions that they need to make in order to do a job done correctly. The smart thing for us to do is going to be to start looking at how the gaming industry solves some of these more complex problems. If you look on here, they achieve that through the use of smart iconography, the way that the icons are constructed so that I can perceive, very intuitively, what is this thing? Is this a factory or is this and this is a really bad example because honestly I don't know what that thing is. But let's look at another one that I love. This is World of Warcraft. World of Warcraft and Blizzard, they follow the second rule of game design, and that's you can either do it first or do it best, and Blizzard does it best. So if you look at the interface that's structured here, you notice that they're playing a game, keep in mind, so please understand we're not going to be developing cybersecurity tools that have you running through a three-dimensional environment, fighting off viruses or something like that. Although that would be kind of cool. But you see the way that they've done the user research, and then they've structured the interface around the way that the user thinks. That means these tactical elements are here. This is a human problem that we understand things right in front of us, the way that we want to dissect a problem with a high level of focus here. Things on the periphery, the icons up in the top right-hand corner, the mission status, things like that. Even these icons here, for anybody that's played World of Warcraft, you don't need to see much. You don't need to see an explanation about what this icon does to know that that's going to summon your hawk companion. I mean, come on, it's obvious. The way that the icons are constructed allows us to do the interaction with a periphery type of focus rather than a tactical level of focus. It enables me to make decisions very rapidly. The abstraction of things like health and mana, those things out to the side, it's just enough. I'm not seeing the exact values here. I'm seeing approximations because I don't need it. The user doesn't need that information. So it's about deciding what elements can I abstract, what elements do I need specifics on, and providing that to the user. I'm dating myself. Does anybody remember Pong? Pong was awesome, and it had like 8 data interactions. You have ball speed, ball direction, pal speed, pal direction. Very simple, but it was very challenging. Modern MMOs can have up to 30,000 different data interactions. But we're not drowning in it unless you're me and you're playing this team from South Korea that keeps kicking my tail. We're not drowning in that data problem. We're thriving in it. In fact, kids nowadays and a lot of adults, some of us, are able to really succeed in that environment because the way that information is structured. The human mind is capable of perceiving those high levels of data if it is designed in such a way that the human mind can accept that data. Yes?
But we're not going to be designing World of Warcraft, and we're not going to be running through it, hacking into it.
Yes, probably not. Probably because it invokes three-dimensional. In this particular case, because it invokes things like three-dimensional space and the constraints associated there. Remember when I said visualization has consequences? Every time that we have to be very careful about what we adopt and what we don't adopt. And I'll give you a good example of that in just a second. Because when we introduce a visualization that looks like something that humans are very familiar with, we tend to subconsciously introduce the bias about that environment. So it's a possibility that we would end up solving that, but we introduce the concept of 3D spatial environment, which doesn't necessarily exist. But it doesn't really matter how far they go. It just matters if they can go.
So have that in this kind of environment?
Sure, and that's a possibility. It really depends on. In fact, that's one of the things we mentioned before is the user is whoever's using the system, not you. It's not me specifically. If that's the general, that means he needs to have a different approach and a different interaction with the data than the practitioner does. So determining who is the vulnerable user and who is the influential user is critical there. And by vulnerable, I mean the user that needs the data but has no say, and the influential user, the one that has the data and has the say. So it really depends on the use case there. But here's a good example where we've tried to apply that. And to get the learning element out of BSides here, I'm introducing a concept that may be somewhat disruptive to the industry because we have a very STEM-centered type of focus. I think the industry needs to open their arms and start to accept some more squishy fields to start helping out these solutions. Cognitive psychology, design thinking specifically. Designers and psychologists need to start having conversations with cybersecurity professionals about how do we perceive this space? How do we design the space so that I can see it? Bring that in. These are my domain understanding. These are my cyber guys right here. And then with the new kind of emerging field of data science, because we have data sets that are so huge, we're going to have some new approaches to it in order to make intuitive and effective interfaces. I want to give you guys a couple quick examples about what some of this stuff looks like. This is what we call a user persona. It has more than the detail than you would think that you need about what is this user going to look like. So as we're doing user research, we actually build models of these users. And we have a generic John DeMunn right here, this guy this is how he's going to use this information. And that's not just a go back to remind us, hey, this is the guy that we're supporting the American soldier, or this is the guy that we're trying to design for. We get very intuitive, very narrative-based type of information about how they will interact with a particular set of data. Because as we're brainstorming and designing and bringing in other topologies or leveraging other examples, we can see very quickly, is this going to meet these user needs? Is this going to trigger him for tasks? How does he approach the behavior? This is one of the reasons it's critical. This is a user workflow for incident response. You can see we have a huge number of different decision elements in this tree. This is quite unlike anything that you'll see in the commercial space, where the user workflow is, I want to send an email. I open up my email. I type into the email block. I click send. That's essentially what Apple's email workflow looks like. Here we have a lot more components associated with that, but by taking user-centered workflows against a user persona, we can identify at each step, are they making the right decisions? When we move that to the interface, we can say, is the interface helping or hurting this type of scenario? Where can we short circuit? Where can we give this information here in order to short circuit that workflow? So I want to give you guys a couple examples that we gave for DARPA on how we approach this. Number one, their initial approach was, and we actually received this a lot, is they said, what we want is a minority report style interface where I've got everything in front of me and I'm whipping it all around and I can see all the information, make decisions very fast. And I said, that's a great idea. Now I want you to hold your arms out just like this for 30 minutes or maybe for an 8-hour shift and see how long you want to do that. So we introduced the concept of media ecosystem. As we have different conversations, as we do different workflows, we have to be agnostic in the way that we approach the design solutions. It's not, I frequently hear either the minority report thing or, can you make it like Facebook? Can you make it like this? We tend to want to bring in design things that design ideas that we've already seen without going back to the way that the user interacts. So specifically, we introduced different ways of approaching the data depending on the roles. So this is the solution to, I want to see the entire internet simultaneously. It's all there on a tree that is a dynamic morphology that manipulates in shape based on what you want to see. Now you'll see right away with the ability to pull different screens about what's going on at each node. So you can see everything is trunked, and where my source nodes are here and potential destination nodes are there. There are things that I can infer immediately about about what that network looks like based on the shape of the tree. In fact, we modified a Israeli graphing motif to do this. But the yellow that's the target area of interest. But you see on the right, we have this Operation Low Volt that we've introduced to them. All they care about was things like how many nodes are potentially going to be affected by this cyber offensive capability. What is my total nodes that I'm seeing now? Things like this red damage estimate, green damage estimate, these are abstracted values because, again, we're looking at a soldier who's just picking from a group of tools that are kind of pre-canned type of scenarios in order to engage a cyber attack. That's all he cared about. What's the speed? What's the effect? What's the stealth? A 4 stealth doesn't actually mean anything. It's an abstracted value to convey that meaning to the user. What's the level of impact? We don't need to give them the detailed description. So that's the solution that we came up with. And I wanted to give an example of where we got it from so that you guys didn't think that, hey, he just kind of made that up on his own. We're able to use things like insights from other industries. This is a tree showing connections and representations between various species. Where they are on the tree, where they are on the branches, represents how closely they might be connected. When we have things like very interconnected networks, especially in cyber warfare, it's extremely important to know if I take out this section of the power grid, am I going to take out an orphanage or a hospital at the same time? So being able to see that type of information is critical. We introduce very intuitive ways of looking at the network in terms of the steps that it takes to go through specific nodes in order to get to the target node. There's all kinds of other network traffic that's there, but the user can't see it because he doesn't need to. The system decides which information is relevant from a pathing perspective, and everything else is obfuscated off screen so as to reduce cognitive load. And we see very simple things, very simple iconography to give me messages about that target node. We leveraged, actually Madden for this one, the ability to bring in kind of the can-play type of approach where I recognize what that play should look like and I recognize the attributes associated with that without representing the entire hash or all the specifics of the target and loading it in order to execute that type of attack. Again, this is all about reducing the amount of stuff, the amount of the amount of germane cognitive load to the user so they can make very quick decisions. This is an example of the industry starting to do it right, where you start to see we have that same kind of network topology map that you saw before, but the difference here is we've got these red highlighted elements. We have correlations to time, we have correlations to IP address here, where everything is starting to work together. This isn't the right solution, but it's moving in the right direction. Also, if you guys look up Tenable Network Security, they've got a pretty new tool that they're using that kind of combines this mesh network with this kind of forced 2.5 dimension type of perspective to give you better information about what the networks look like. They're doing great things there. So really I'm hoping my takeaway for you guys is just that the community, the cybersecurity practitioner, will start opening up their arms and looking for areas of cognitive psychology, areas of visual and interaction designers to start to help us solve this big complex problem that we've created. So, any other questions?
Outside of DoD research,
No one. In fact, it scares me a little bit because there's lots of research in cognitive psychology, especially in the field of learning, how to teach different things. But in terms of applying that to how do I solve these complex problems, nobody's doing it. I know it's scary to me. Yes, sir. Tons, because they're doing it right, but it has to start with the user is the king, essentially. The user research is the king in this case. the gaming kind of community has the ability to kind of create stuff in abstract all the time. So you don't want to totally leverage everything there. Plus, in a lot of cases, the user is not used to gaming. That's something that we ask all of our users is, how much gaming do you do? If they don't do any games at all, we don't want to introduce concepts like the concept of a mini-map. Everyone that plays games can go in there and be like, oh, yeah, mini-map. I spatially understand exactly what that data is represented to me. But if they don't have any connection to gaming, that's going to be a harder thing. We wouldn't want to force that on a user. So. Quite a bit, especially in the data science area. So, I didn't want to go over, sorry. Okay, thank you.